Today I will present how to create a subnet network configuration using a class B IP address in Cisco Packet Tracer. My name is Shantanu Mondol, a MTech NIS student of Department of Computer Science at Pondicherry University. I am excited to guide you through this process. Let's dive in. Here's the problem statement for our task. We need to create a subnet network configuration using a class B IP address in Cisco Packet Tracer. The objective of this exercise is to understand how to subnet a class B network and configure resulting subnet in CPT. We are given the IP address is 172.16.0.0. And our goal is to create 8 subnet from this this address. Additionally, each subnet should have at least 4 endpoint of node. This will help us to grab the fundamental of subnet and its practical application. So now we will understand the process of subnetting and IP, which is required few steps. Step 1 is identify the class of IP address and determine the number of bits involving in network ID and host ID. Step 2, identify how many subnet we need to create. And step 3, calculate the minimum number of bits required to represent this number of subnet. And step 4, borrow bits from the host ID. Take the required number of bits from the host portion of the IP address and add them to the network portion. Now step 5, calculate the new subnet mask by converting the binary representation of the new subnet mask to dotted decimal notation. Step 6 is the increment calculation. Now we will need to calculate the increment of IP in each subnet. Step 7 is calculate usable host address or number of node we can connect in each subnet by using the formula 2 to the power n minus 2, as we keep first IP as network ID and last IP as broadcast IP. Now in step 8, we will assign all the IP to each subnet. Our task 1 is to subnetting a class B IP address into 8 subnet, and the network ID is 172.16.0.0. First of all, a class B network has 16-bit network ID and 16-bit host ID. Now let's say we need to divide this network into 8 smaller subnet. To achieve this, we need to borrow bits from the host ID portion to calculate a subnet ID, because we cannot touch the network ID. Calculating the minimum number of bits required for subnet ID is easy. We need 3 bits because 2 raised to the power 3 equals to 8. By borrowing this 3 bits, we are equivalently divided our network into 8 smaller subnet. With this 3 bit, now part of the subnet ID, we can calculate the subnet mask. It become 255.255.224.0, which we have also represent in binary form. The final step to determine the increment of assigned subnet address. Since we are borrowing first bit from third octet, which is 1110000 in binary, this increment will be 2 raised to the power 8 minus 3, because 3 bit is used for subnetting, which is equivalent to 32. Now let's figure out how many computer we can connect to each subnet. As we have 13 bits is remaining, to 2 to the power 13 is equal to 8192, but the first IP is the network ID and the second last IP is the broadcast ID. We cannot use them, so the usable IP we can assign to any computer is 8190. So we can connect 8190 endpoint to each subnet. Now we'll assign each subnet number, network address, broadcast address, and usable IP range in a given below table. We can see the table content subnet number 0 to subnet number 8, and the network address which is the first IP of this subnet, and the broadcast address which is the last IP of the subnet, and the usable IP range which we can assign to any system. Now let's go to the Cisco Packet Tracer to see the network configuration. This is the terminal of Cisco Packet Tracer. We can see the network configuration. we connect each PC to its corresponding switches, and each switch is connected to the router using the Ethernet cable, and we use the gigabit Ethernet. So we can see we have write all the subnet ID and a range, which you can assign the IP address and broadcast IP. We connect each PC to the switches. For like subnet 1, we have added 4 PC, and we have given the IP for each PC. We have assigned IP for each PC, which is also written down here for our understanding purposes. So we can see the third PC of first subnet is the IP is 172.160.100. We can go to this PC and go to desktop and go to IP configuration. We can see 172.160.100. This is the IP, and the subnet mask will automatically generated. And we can go back. We have assigned each IP like this for 8 subnet. I have connected 4 PC to each subnet, so 32 PC has been connected in this network, and 8 PC has been connected to this router called 8321 router, and the switch I have used is 2960, and for the endpoint I have used all the PCs to use. So we can just check this network by sending a ping message. Like if we want to send a ping message to to subnet 6 third PC, we can go here, we can go to desktop, we can go to IP configuration, we can copy the IP here, and we can, if we want to send we can go to second subnet third PC, and we can go to desktop, and then command prompt we can write ping, then paste the IP, and we'll send the package to this IP from this PC to that PC, and we can get the reply from that PC. We sent 4 packages, and we are getting the reply successfully. So we can conclude that our network is working fine, and we can do a simulation. For this, we will on the simulation environment, we will take a packet, and we will click for the sender. If we want to connect the third PC, and we of the second subnet, and we will send like 8 subnet first PC. We can just on the simulation process, and we can see it is happening it is doing the simulation, and it is in progress. After completion, it will show successfully. We can fast forward this by clicking here, and we can see it is happening. It will the destination on it will send all the nodes of the network, and the destinations node is only accepting the message and send a acknowledgement to the source. So it is happening, and that is happening. So this is showing the successfully it sent the message, and the sender get a successful acknowledgement. So